So guys, today we'll see three things, okay? One is NTP with authentication. Last time, I guess in VPN class, I had gone through this. How many of you haven't attended NTP with authentication class? In evening class, I have gone through this NTP. So is there anyone who hadn't attended this NTP with authentication? NetFlow and we'll say uRPF. These three things we'll see. Hey, it means all of you have attended NTP class in evening, right? All of you. Question was for everyone, not for one guy. Nidesh, Shiva, all of you. So if NTP is already done, then we'll skip this. NTP you guys already know. I don't need to repeat it once again. Let's complete this. NetFlow uRPF. See, this NetFlow and RPF, uRPF are like L3 securities. Okay. So that comes under the NetFlow comes under the telemetry. Okay. And uRPF comes based on the layer 3 security. So first of all, let's do a practical of a NetFlow. Then we'll come to uRPF. So NetFlow theoretical part we already discussed yesterday. We don't have to discuss it again. I'll create a new topology. Here we'll create for, let's say, NetFlow. I'll take 3 routers. Oh, I took switch. R1, R2, R3. We'll connect it. Let me configure IP address. So first of all, let's start all these devices. Let me configure IP address. On R1, I'll configure like enable configure terminal, host name R1, interface G0 by 0 with the IP address 10.11.11.1, subnet mask 24, no shut, exit. I'll give a IP route, a default route towards the 10.11.11.2. Okay. I'll configure for R2 G0 by 0 interface will be .2. I'll configure G0 by 1. And here I'll put like 192.1.20.0, sorry, 20.2 as an IP. Finally on R3, here I'll put 192.1.20.3 and gateway will be 192.1.20.2. Okay. So let's quickly copy and paste all these configurations. Let us take console access. I'll configure. Okay, R3 done. R2 done. And R1 done. So now I'll try to check connectivity between these two sites. Okay. So let me come to R1. 192.1.20.3 and I have a connectivity. So basically, I want to capture the packet here at this interface inbound direction. Means per interface you can apply your NetFlow. Okay. So basically, whenever you are sending a traffic or sending a traffic to R3, I can set at any interface in particular direction. Either I can set here as a outbound direction, either here I can send a outbound direction, or I can send here as a inbound direction. See, why do I want to set here as a inbound direction? Because if anyone is trying from here, that also can be captured. Or if anyone is trying to go from here, and if R3 gives a reply back, again, packet will be captured here. So this is my intention. So I want to capture the packet at this interface. Okay. And the informations will be shown in a template wise. Template wise means per traffic, what type of traffic details it is. Like template wise, all the informations will be collected at one place. So per protocol, like for ICMP one template, for TCP another template, like that. So I want to capture the packet here. I want to see how the net flow, how your traffic flow is happening in the network. I want to see these informations over here. So let's configure a net flow over here. You'll say flow exporter, I guess. Exporter and plus the question mark. It says you to define some name. Let's say I'll write a name here as exporter. This is just a name, nothing else. Here I'll define a destination, and you have to define what's your destination host. I can define 192.1.20.3 as a destination address. And I can define one more thing here. If you press a question mark, you can see many options you guys have. All right. So inside this, I can also go for transport UDP. There might be some transport command. Okay. Transport, press a question mark, UDP, press a question mark. Now, let's say, for example, see by default, what happens? There is an application also for a NetFlow. NetFlow application is there, which by default works with the port number like 9996. You'll have a NetFlow applications also that can be used. You can see NetFlow Analyzer or NetFlow Analyzer. You can search for. So multiple vendors, you can see NetFlow Analyzer. You guys can get it. You can download it. So when you download and install, and if you want that NetFlow, the application to get linked with this router, or the information generated on this router should go to that application, then you can define the port number over here. So transport to UDP port number what? Basically what happens, you can define that, the destination IP address, you can define the UDP port number on which it basically works. When you open that application, it will show you that application is working on any port number. So you can define that port number over here, UDP port number 9996, something like that. If you guys are not using, then you can delete this particular port number. No need to configure this. After that, you can say export protocol, and here you can see the versions, different versions of your NetFlow. So currently you can see NetFlow version is 9 over here. So I can select it. Okay. And I can define what's my source interface. So if you define here, okay, in my case, it's like G0 by 1. I want to define as a source interface. I want this interface to be configured wherein the packets should be captured. Okay. And then I'll exit. This many commands you will configure under the exporter. After that, you have to configure flow monitor. Press question mark. It is asking you for a name. So I'll configure monitor as a name. And here you have to define record NetFlow. If I'm not wrong, it's IPv4, correct. IPv4, press question mark and define the original input. I want the original input, not the output. I want the input. So I want to record the input, right? And I'll define exporter. What was my exporter name created above? It was name with exporter, call it here. So once your monitor is ready, now you guys can get into the interface G0 by 1 and apply here. You'll say IP flow monitor. And what's my monitor name? My monitor name was monitor, I guess. Configured in the capital letter right now. This one. And direction you have to define. So we'll apply in the input direction. So if any traffic is hitting at this interface in direction, no matter it's a reply or it's a source, does not matter. In both the cases, the packets would be captured here in the inbound direction, right? So I can go to R2 and check, like I can say, so flow monitor name I can give as a monitor. My monitor name I can give here, and I can press enter. So currently I haven't any type of, the information's captured over here. So let me do one thing. I'll go to R1 and I'll try to communicate to R3. So I'll go to R3 and here I'll configure line VTY 04, password as a Cisco, transport import telnet. I'll try to telnet from R1. So I'll say telnet 192.1.20.3. Login here. I'm on R3. So let's see on R2. Say cache. Okay. Okay. So you can see here source IP address R3. Why did it show as a source IP address as a R3, guys? Actual source was a R1. Why did it show the source address as a R3 in the template? This is one template created for the current traffic to gather all informations. So tell me, guys, why did it define or why did it show R3 IP address as a source IP here? Give a complete answer because it captured a reply packet in inbound direction. Correct? That's the reason. That's why R3 has been shown here as a source, and here it is shown as R2 as a destination, right? So packet hitted at the R2. Now, there is no translated port number and all. This was a destination port number, okay? And here you can see source interface was this. It means input interface. I mean, like where the packet got captured. Subnet mask was /24, okay? First attempt and last attempt, okay? Or you can say timestamp, first timestamp or the last timestamp, okay? Now, this is what we got the information right now. Let me try again something. I was supposed to get the port number details also. I didn't get source port number, destination port number. I didn't get the port number information. Let's try it again. Exit. Again, let me try telnet. Let's check a cache memory. Okay. So guys, now can you see here? Now this is what the correct information is showing. This it was supposed to show as a correct information. There I was having some doubt because in a destination it was showing R2 IP. Now here you can see source IP address as a R3, destination as a R1. Source port number who gave a reply. In a reply, source port number is 23, destination is a dynamic port number. And this is an interface where it captured in the input direction. Next hop was actually this to whom the packet was forwarded. Subnet mask for source and destination was 24. And this is the first timestamp, and this was the last timestamp, and total counter of packets were 30. So guys, did you understand what is NetFlow? Do you think this will work in a big environment? For small organizations, these are fine, right? Not for big organizations. Now, if I ping, let's go to R1. Let me ping to 92.1.20.3. For ICMP also, I must see timestamp. Can you see guys protocol number 1 used here? 2 templates. This was the actual correct one. So I can see the source IP, destination IP, protocol number 1, that is ICMP. So like this, you can see the informations here. Everything will show you in a template wise. So for a small organization, this is fine, not much scalable. For big organizations, these are outdated, not required. But NetFlow is taken support in multiple devices. They use a NetFlow protocol in multiple devices, like Stealth Watch also takes a support of NetFlow. Okay. So this I could not ignore it, because further you will see discussion of a NetFlow in other devices also. So it was important to put in your mind. So NetFlow is done, guys. Now we'll discuss about uRPF. Have you guys done any research on uRPF? What is uRPF? Yesterday I had told you guys. Any idea about uRPF? Tell me, what is uRPF? Unicast reverse path forwarding. Okay. Tell me, what's the use of uRPF? Prevents the spoofing attack. Spoofing attack for what? MAC address, IP address, DHCP for what? Okay. It is basically used for prevention of IP spoofing. That's correct answer. Now tell me, how does it do? How does it work? How uRPF works? Just tell me, like, how does it work? That's it. It will enable uRPF on the outside interface. Router will check the path to reach the source IP of incoming packet. Okay. So what will happen if it checks? If it does not find, or if it finds, what happens? I want to know. Works by enabling a router to verify reachability of the source address in a being packet forwarded. Okay. In a packet being forwarded. Okay. If there is no path to reach the source IP, it will drop. Okay. Got it. So you guys have almost the idea. This is correct. See, uRPF is all about, it checks a routing table. Okay. Generally what happens, guys, whenever you send a packet to one place to another place, from one source to another destination, so how does the packet gets forwarded? Based on the source IP or destination IP? Packet always gets forwarded based on destination IP. So that's packet forwarding. That's not uRPF. Okay. So don't compare the destined packet with the uRPF. That's not a uRPF. uRPF basically can be applied at outside interface, or can be any interface of the firewall. Per interface you have to apply. It's not like one interface you applied, it will check at the other interface also. So wherever you want, you can apply as per your requirement. So what uRPF it does is, whenever you are sending a source and a destination IP, in source and destination IP, let's say this is source and this is my destination IP. So based on the source IP, it will check, like, whether R2 has the source IP's route in a routing table or not, no matter it is directly connected or indirectly connected. If someone is sending the packet to my network, and if my router does not find the route for that particular IP address or for that particular subnet, then my router will drop the packet based on the source IP, not based on the destination IP. So attacker knows the destination IP, but attacker does not know that we can also filter the packet based on the source IP. So let's say here is an attacker. Attacker is having an IP address from 172 network, and he's trying to attack the packet here on 192. So attacker knows that I need to do attack on 192. So he sends a packet to 192. He thinks, okay, there is already a route for this particular packet, so my packet will get routed. But he does not know, in between there is a uRPF device wherein it will find that based on the source IP, if it does not find 172 network, route in the routing table, packet will be dropped here itself. Okay. So it's all about filtering the packet based on the routing table, okay, to prevent your IP attack or layer 3 attacks. That's it. So here you have a small configuration, not a big configuration. Let me show you. How many of you guys are aware of infrastructure ACL? Okay. How many of you are not aware of infrastructure ACL? What is infrastructure ACL? Okay. No idea. Good. I'll tell you. So basically, I was supposed to discuss about infrastructure ACL first, then come to uRPF. Okay. So guys, I'll go back to infrastructure ACL once, and then again I'll come back to uRPF. See, basically what happens in infrastructure ACL, like we deny the unknown packets coming. Let's say, for example, guys, the attacker, if it comes from internet with a private source, do you think that packets would get accepted? Now, let's say this is my company router, which is connected with internal network and external network. On the, I'll take one router, assuming this is my ISP. On this router, I'll create one loopback. Through this loopback, I'll try to send the packet to this interface. I'll try to create a DOS attack. Okay. So basically, I'll make a source as a private IP and I'll try to send the packet to a public IP. So packet will get forwarded based on the destination IP. That's my public IP. Packet will get forwarded because public IP will get routed. But when the returning packet will come, it will find there is a private IP, so packet will get dropped at ISP. Understand? So basically what I'm trying to tell, why should I accept the packet from the source of a private IP or any packet or any subnet of the private IP? I should not accept the packet. Okay, that's basically an infrastructure ACL. So what you can do, you can deny such type of range of IP addresses from where you should not accept the packet. So can you see here the source IP here, a source subnet, 10 subnet, 172 subnet, 192 subnet, all the private IP, all the private ranges. Now, if someone tries to send a packet from 000, guys, getting point, right? 00, I don't want to accept. Where in source, if it is 000, all the fields as a 0 to any destination, like saying you want to ping like this, 0.0.0.0, like this. If some attack is happening in this case, right, it should get denied. After that, loop back, and there is one certain range of your 192 subnet, 192.0.2, that also comes under the special case of your IP. After that, you have the multicasting and you have the APIPA. So these are the special cases from where we don't expect any routing in our network. Have you ever seen doing any routing or working based on the APIPA or multicast? Have you seen that? No, right? And why should I get the packet from the internet with the private IP? So that's basically idea of attackers. They'll make themselves source as a private IP and destination they will put as a public IP, right? And they will try to perform the attack. So packet gets routed based on the public IP. So packet reaches to our destination, and as an attacker does not want a reply, so and as a attacker they don't want to get tracked. So what happens when the internal guys, when they try to track who was a guy who tried performing the attack, they find a private IP, and private IP can't be tracked through the internet because they don't know from where the packet has come. So this is the way of performing the attack. So if you have to apply infrastructure ACL, then these are the ACLs that should be denied. A range of IPs or the subnet, you can say, deny it and apply it in the inbound direction at your outside interface. That's it. This is called infrastructure ACL, and this is layer 3 security. So it's quite similar to infrastructure ACL. Day by day, what is happening? Now we guys are leaving such type of the configurations. Now these are these solutions wherein they are not using a firewalls, they don't have a, or they can't afford the security devices. In that scenario, such type of solutions are used. In their enterprise network, let's say they don't have firewalls for the auto traffic filtering and all. In that cases, they put such type of solutions. So basically, Cisco's intention is small or big organization, those who can afford firewalls and all, for them this uRPF and alls are not required. Those who can't afford, those who want to secure their network based on limited resources, for them these solutions are. So basically uRPF is going to drop the packet or drop the source IP address which does not match the routing table for that interface. As I told you, per interface it will be target to drop the packet coming from the unknown address. It is used to block IP spoofing. Automatically checks a source IP address of the packet against the FIB. That's your forwarding information base. So this is what uRPF is configured. It's very simple. We'll create one ACL with having a log. At last, you can see it's a written log. I need a log to be generated. I'll go to a particular interface and I'll apply. Verify unicast source reachable via RX 100, give some number. And after that, go to a particular interface. Okay, IPVRF, same thing. What's my ACL number here? 100. So applying that ACL number here. And what's the action here? Deny from any source to any destination and say log. And go to this unicast and apply that ACL, which has action as a deny. So basically, uRPF with ACL action, we have applied at both the interfaces. So no matter through any interface, attacker tries to reach, you'll get the log wherein packet will be dropped if the source IP's route is not in a routing table. So let's see this part. Okay. This is what you guys have to do. Simple few lines. Same configuration I'll add, and also I'll add interface loopback one with the IP address 10.1.1.1 to our destination. Sorry, with the subnet mask as a 24. This is what I have done. I created one loopback. I'll take this configuration on R1. Let me take configuration of R2. So we'll try to check a reachability. I'll go to R1. I'll try to ping 192.1.20.3. I do have a reachability. Let me try to perform the attack. Let's say I want to perform the attack on R3. Here I'll say debug IP ICMP. I want to send unnecessary ICMP packets. Okay. So I would try to ping this destination with the source as my loopback one. Okay. And I can, size a packet. I can even size the packet like of how much I want. And okay, or I can go with a repeat, like 100 times I want to repeat the ICMP packet. Okay, so if I press this, You can see continuously my ICMP unnecessary packet is hitting to destination, and my R3 is trying to reply back to this IP address, which it does not know. So basically, I don't want this attacker. Okay. So the loop back of R1, I assume it as an attacker, which should be dropped. Okay. If I check my routing table of R2, here if I say so IP route, here I can see my directly connected networks are 10.11 and 192. I don't have any route for 10.1 subnet in my R2, right? So basically, see, till now ICMP packets are going on till 100 packets. It will go to a destination. It is trying to slow down my router, unnecessary packet sending. So this loopback is trying to create unnecessary attacks. Now it might, you know, increase the ICMP packet size. It might not send a normal packet. It might increase the packet size of the ICMP. It might continuously send it for 1,000 times. So why to utilize the resources? Why to receive unnecessary packets on my internal network? So being these reasons, I want uRPF to be applied. So let this packet to complete. So I want on R2 both the directions. On R2 both the directions, I want uRPF to be applied. So unnecessary packets can be saved from coming to my network. See these many unnecessary packets coming to your network. Why do I need to receive so many packets? Continuously receiving. But it's not getting cancelled also. Control C. I guess it will complete 100 times. Control Shift 6X. This is also not working. Control C not working. Control Z also not working. Okay. Let it complete 100 times. Wait for that. Done. So unnecessary packets I was sending. So what you guys have to do, just create one access list, right, with a deny with source and destination as a any, and at the last say, log. So basically I want the log to be generated. So let's go to R3, sorry, R2, middle router, where you want to filter it. Okay. And you'll create one. You'll go to a particular interface. Okay. And you'll apply it. Let's say interface G0 by 0. Okay. And you'll apply IP verify unicast source reachable via receive RX. TX means transmit, RX means receive. And if it does not match the routing table, then deny the packet using this access list. So you can say this access list is used for filtering in uRPF, filter ACL. So apply this. And if you want, you can apply it to interface G0 by 1 also. Same thing. Okay, that's it. Applied. Nothing else you guys have to do. Now simply check R1, R3. I'll try to perform the same attack just for 10 times. Guys, on R3, is your packet getting received now? Is your ICMP packet reaching on R3 now? No, packet is not coming. And if you come to R2, you will see a log getting generated. So denied for this particular host IP while reaching to this destination at 0 by 0. Am I clear with the uRPF, guys? Okay. Guys, tomorrow we'll have a last class of this. Okay. So tomorrow we'll see dynamic routing protocol authentication. DRP authentication. We'll see on router and we'll see on ASA firewall. This will be one of the most important topic according to examination perspective. Okay, and we'll finish it up. Not sure about it, Nidesh. You need to confirm with management. Firewalls, I'm aware. CS, I'm aware. Not sure about AWS. Please check. Take care.